Good morning, students. We'll start with the today's lecture. Okay, in the previous lecture, we have seen how to construct the root locus and how to judge the stability of the given system, right? So we'll continue with few more numericals on root locus and how to judge the stability of the system. Then next we'll see how to graphical determination of k for specified value of z, means for a particular damping ratio z, how to calculate the value of k. Yesterday we have seen the graphical determination of k, right? That is k is equal to product of phasor lengths of poles p1 p2 p3 and so on divided by product of phasor lengths of zeros z1 z2, that we have seen, right? Okay, next we'll see the graphical determination of k for specified value of z and the concept of dominant roots. All those things we'll study and we'll wind up this chapter, and we'll start with the next chapter in the next class, right? Okay, yesterday I had given homework, this one has homework, but how many of you solved? I don't know. Let me solve this problem. So this is the root locus, how it looks like. Okay, let us take and we'll solve it, right? I'll take in the next slide. G of s into h of s. Okay, question is here. G of s into h of s is equal to k divided by s into s plus 2 into s plus 4 into s plus 8. Sketch the root locus and comment on stability. This is how the root locus looks like. I hope few people have done it. Okay, let me solve it. Step 1. So how many poles are there? So 1, 2, 3, 4. Totally for highest power of s is 4, right? So 4 poles are there. They are located s equal to 0, minus 2, minus 4, minus 8. Then how many zeros are there? No zeros. So no zeros. So p is greater than z because p is 4, z is 0. So the number of branches of root locus is equal to p, that is equal to 4 branches are there. Okay, then starting point of branches starting point of branches are nothing but the poles here, right? 4 branches are there. All the 4 branches will start from this poles 0. One of the branch will start at 0, another branch minus 2, another branch minus 4, and another branch minus 8. So these are the starting points: 0, minus 2, minus 4, minus 8. Then terminating points, these are the starting points. Next, terminating points of branches. Okay, since no zeros are available, so all the branches will move towards infinity. From 0, this branch will move towards infinity. From minus 2, this branch will move towards infinity. From minus 4, this branch will also move towards infinity. From minus 8, this branch will also move towards infinity, right? The next, step 2. Okay, what is step 2? Can you help me out? Step 1, we have collected all the information, right? We have to draw the pole 0 plot, right? Yes or no? Yes? Yes or no? Yes? Okay, will never respond, I think. Pole 0 plot. Okay, we'll draw the pole 0 plot. Sigma j omega. Okay, we'll look at the poles here. So I'll change the ink color. 0, minus 2, minus 4, minus 8. Okay, let me extend this. Let me take red ink. So let me change the ink color. Minus 8. Okay, 0, minus 2, minus 4, minus 8 are the locations of the poles. Then next, no zeros are there. Whether the root locus exists in this section or not, okay, we'll check it. So let me consider one point here. To the right of it, only odd number, only one pole is there. So there exists root locus here. So root locus exists in this section. Then let me check for existence of root locus in section minus 2 to minus 4. If I consider a point anywhere here to the right of it, if I count 2 poles are there, it is even. So there is no root locus here. From -4 to -8, let us take one point here. To the right of it, if I count 1, 2, 3 poles, it is odd. So root locus exists here. Root locus exists here. So root locus exists here. Then let me shift the point from -8 to -infinity. If I shift the point here, 1, 2, 3, 4. So even number. So no root locus exists from -8 to -infinity. So root locus exists on the real axis only from in the section 0 to -2 and -4 to -8. Okay. Then we will predict how many minimum breakaway points are there. These two are adjacently placed poles and this is a part of the root locus. So one minimum breakaway point exists here. One minimum breakaway point exists. Breakaway point exists. And these two are adjacently placed poles once again -4 and -8. So here also one minimum breakaway point exists. One minimum breakaway point exists. BAP I have written, breakaway point exists. Okay. There are two breakaway points, one in the section 0 to -2 and another in the section -4 to -8, right? And you can see the branches, how they will move. I will show you the direction. From this 0 pole, the branch will start and it will move towards this breakaway point. Another branch will start from -2 and it will move towards this breakaway point. Second branch. Third branch will start from -4 and it will move towards this breakaway point. And fourth branch will start from -8 and it will move towards this breakaway point. And how they will depart. Observe here. So two branches are approaching this breakaway point. So yesterday I told plus or minus 180 degree divided by n. So at this breakaway point, how many branches are approaching? Two branches. So plus or minus n is 2 here. So n is equal to 2. So I will be getting n is 2 means 90 degree plus or minus 90 degree. So this branch will start from 0 and it will move at an angle. So let me take green color only. So it will depart at plus 90 degree. Another branch starting from -2, it will depart at -90. Only this much will extend, right? Then here, once again, if I consider this breakaway point, two branches are approaching. Once again, plus 90. Another the branch starting from -4 will leave this breakaway point at plus 90 degree. Another branch starting from -8 will leave at -90 degree, right? This much is sufficient. Okay, we'll go to the step 3. If any doubts at any point, please unmute yourself and talk to me. Step 3. I hope it is asymptotes, right? Asymptotes. Theta is equal to odd multiple of 180 degree. 2q plus 1 into 180 degree divided by p minus z. And q runs from 0, 1, 2 and so on till p minus z minus 1. So what is p minus z minus 1? We'll find out. So p is 4, z is 0 and so it is 4 minus 1 is 3. So q can take only values 0, 1, 2, 3 till 3. Q can take 0, 1, 2, 3 because till p minus z minus 1. P minus z minus 1 is 3. So Q can take values 0, 1, 2 till 3 only. Then what is p minus z? Because I want in the denominator. So 4 minus 0. It is 4. Okay. We will find out all the angles. For Q equal to 0, the angle is theta 1. We will calculate. For Q equal to 1, it is theta 2. For Q equal to 2, theta 3. For Q equal to 4, it is theta 4. Okay, we'll try to find out. So let me, okay, Q is 0. So 180 degree divided by 4 because P minus Z is 4. So 180 degree divided by 4. So 180 divided by 4. So I am getting it as 45 degree. Then substitute Q equal to 1 here. So 2 1 are 2, 2 plus 1 3, 3 into 180. So 180 into 3. So 540. 540 divided by P minus Z is 4. So 540 divided by 4, it is 135 degree. Next, substitute Q equal to 2 here. 2 2 is 4, 4 plus 1 5. 5 into 180. 5 into 180. So it is 900 divided by 4. So it is 225 degree. Next, substitute Q equal to 4. 4 2 is 8, right? 8 plus 1 9. 9 into 180. 9 into 180. So I am getting 1620 divided by 4. So I am getting 405 degrees. So Q equal to, sorry, I have made a mistake. It is Q equal to not 4, it is 3. You should have corrected. No, nobody will correct me. If I make mistakes, you'll keep quiet. That should not happen. Q equal to 0, 1, 2, 3, right? So 2, 3 just 6, 6 plus 1, 7, 7 into 180. 7 into 180. So 1260 divided by 4. So 315 degree. So please, if I make any mistakes, immediately you respond, right? Or else everything will go wrong in further, right? Okay, fine. So angle asymptotes are calculated over. Next, step 4, we will calculate the centroid, that is sigma. So the formula is the sum of the real part of poles minus the sum of the real part of zeros divided by p minus z. Okay. Okay, sigma. Sum of real part of poles. What are the poles? 0, -2, -4, minus. There are no complex part here. Only real parts are there. So 0, you will add all these things. 0 plus of -2 plus of -4 plus of minus. So 0 -2 -4. 0 -2 -4 -8. Right? 0 -2 -4 -8. So we have added all the real part of poles. Minus. There are no zeros. So take it as 0. P minus Z is 4. So we'll calculate this, how much we will get. So -2 -4 -8. So I am getting -14. -14 divided by 4. So divided by 4. So I am getting -3.5. So this is the centroid. So we will, using step 3 and 4, we will try to draw the uh, partial root locus indicating the centroid and asymptotes, sigma and j omega. Okay, sigma is -3.5. Let me try to look at the roots. It's not required. Let me look at only this much, right? Whatever it is there. So let me take this sigma equal to -3.5. Is it fine? Centroid. Then I have to draw all these angles. Theta 1 is 45 degree. So let me change the ink color. So theta 1 with this point as minus at -3.5, take the protractor and measure -45 degree. Sorry, 45 degree. This is theta 1. It is equal to 45 degree. And one more thing you can observe, 45 and 1 alternative 225. Just if I extend like this with the scale, so this is theta 3. So I'll do parallelly. So this is theta 3. Theta 3 is how much? 225. It is 225 only. Right here 90, 180, then 225. The next theta 2 is 135, 90 plus something. So it will come here. So this is theta 2 and it is how much? 135 degree. And theta 2 and theta 4, it is 315, right? Just extend this, that's all, with the scale. It will be 315. So this is theta 4. It is 315 degree. Okay, this diagram shows the location of centroid and asymptotes. Okay, next we'll continue with the step 5. Step 5. I think it is breakaway points, right? Breakaway points. Breakaway points. So we know that breakaway points is given by dk by ds equal to 0. So first we'll get the characteristic equation. 1 plus g of s into h of s equal to 0. So 1 plus, what is g of s into h of s? K divided by s into s plus 2. K divided by s into s plus 2 into s plus 4 into s plus 8. I think it's correct, right? 248. Yes, 248 is correct. Equal to 0. So we will take LCM. Just I will multiply somewhere roughly here. S into, first I will multiply s plus 2 into s plus 4. So s into s is s square plus s into 4 is 4s plus 2 into s is 2s plus 2 4 ja 8 into s plus 8, we will take it. Okay, next s into s square 4s plus 2s 6s plus 8 into s plus 8. So we will multiply s plus 8 with this, right? So s into, I will keep it as it is. I will multiply s into s is s cube 6s square plus 8s. Next I will multiply 8 plus 8s square plus 8 6 48s plus 8 8 is 64. So let me separate out all the terms. Just I am doing the rough work here, right? So s into s cube, so 6s square plus 8s square, 8 plus 6 14 plus 14s square, and here 8s 48s 48 49 50 56 56s 8s plus 48s, right? So 48 58 56s plus 64. Next multiply s. So anyhow I will multiply and write it here directly, right? I will write it here. So like s to the power of 4 plus 14s cube plus 56s square plus 64s plus this one is k plus k equal to 0. This is the characteristic equation, right? Okay, once characteristic equation is formed, separate out k terms one side and s terms one side. So k is equal to, move all the s terms that side. So minus s power 4 minus 14s cube minus 56s square minus 64s. Is it fine? Okay, fine. All the s terms we have moved this side. Then take derivative of k with respect to s and equate it to 0. dk by ds equal to 0. So nx to the power of n minus 1 s cube I will get. Next 14 into 3, how much? 14 into 3, so it is 42. 42 s square minus 56 into 2, 56 into 2, so I am getting 112. 112s minus 64, right? So equate it to 0. So all are positive here, right? So 4s cube minus, right? Take minus outside, and if it goes that side it will be 0. So 4s cube plus 42s square plus 112s plus 64 equal to 0. So this is a cubic equation. So I'll take the help of calculator to solve this. So I will go to equation. So degree is 3, then a value is 4, then b value is 42, then c value is 112, then d value is 64. So I am getting one of the root. Just I am writing. Yes, I will write the root here. Minus 0.785. This is one of the root I am getting out of 3 roots. The next another root is minus 6.652. This is the second root. And let me check for the third root. It is minus 3.061. 3 roots are there, out of which is valid. I have to check it. 0.7 or 6.6 or 3. All are negative only. Just I will take one. 0.7, 6.6, 3.06. Let me check it on the by looking at the diagram. 0.7. Just remember 0.763. 0.763. Just observe here. 0.7, yes, it is fine. 6, it is also fine. 0.7 and 6 are fine because 0.7 will come here. Yes, this is the breakaway point. 0.7 and 6 it will come here. 3 it will come here. 3 is invalid, right? 3 point something minus 3 point. This is invalid. So 0.6, 0.7 and 6 are valid. 0.7 and 6 are valid. So 0.7 this is valid and 6 this is valid. These two are valid. This is valid breakaway point and this is valid breakaway point, and this is invalid. So invalid because this does not lie on the root locus, right? It is invalid. So these two are valid breakaway points. So s equal to minus 0.785 and minus 6.652 are valid breakaway points. BAP side, right? Breakaway points, right? Next, step 6. So intersection of root locus with imaginary axis. Intersection of root locus with imaginary axis. So we have to find out the intersection points. So we have the characteristic equation. Already in the previous step we have done it. So it is s to the power of 4 plus 14s cube, s to the power of 4 plus 14s cube plus 1 minute, just I'll sit properly. Okay, fine. 14s cube plus 56s square plus 64s plus k. So from the root array, using this, from the root array, okay, s power 4, s cube, s square, s to the power of 1, s to the power of 0. All the powers of s are present, 4, 3, 2, 1, 0, fine. So list out the odd term coefficients in first row, 1, 56, k. 1, 56 and k. So k is the constant term, just I will mark it, right? Then list out the even term coefficients, 14, 64. Right, 14 and 64 over 3 elements. 2 elements, only 2 elements will be coming here next. So from here we know that it is k only, right? We know this, right? Then we will calculate this element. So how much I will get, let me check it. So 14 into 56, open bracket, 14 into 56 minus, open bracket, 1 into 64, that is 64, divided by 14. So I am getting 51.428. Okay, I am getting 51.428. Next, two elements, only one element will be coming here. What is that? 51.428 into 64. 51.428, 51.428 into 64. So I am getting 3291. 51.428 into 64, I am getting 3291. 3291.39. 3291.39 minus 14k. Minus 14k divided by 51.428. Then this is constant term will be taken here. Next, I want to make one of the row as row of zeros, but don't take this s power 0, leave it, right? Leaving this, other row should be 0. This cannot be 0, this cannot be 0, but this cannot be 0. This can be 0. So this can be row of zeros. Row of zeros. How? We have to put appropriate value of u. What is that value of k, so that it will be 0, right? So we have to check for that. So what should be the value of k so that this will be 0? So what is that? Let me check it.
Excuse me, sir.
Yes, tell me. Yes, tell me, Prem Sai. Yes, Prem Sai, tell me.
Sir, the second term in S square row,
Ah,
it should be 14k minus 64 by 14, sir.
this one,
Yes, sir.
why?
So we multiply 14,
Up,
14k
up.
minus 64 by 14.
No. See, observe here. See here, I will calculate. Okay, no need to calculate. Actually, this constant term will be taken directly here. Just observe here. See here, if I leave this 14 into k, 14k minus 0 divided by 14. So I will be getting k only.
Yes, sir. Yes, sir.
It is correct. It is correct, right? Okay, fine. Okay, this should be row of zeros. So what is the value of k? Let me equate this to 0 and calculate the value of k. So 3291.39 minus 14k equal to 0. I will equate because I want to find out marginal value of k. Right? 3291 0.39 minus 14k divided by 51 point. I will not take because if it moves that side it will be 0. So I will calculate the value of k. So 14k is equal to 3291.39. So what is the k equal to k marginal value? What is that marginal value of k? So it is, we will calculate. So 3291.39 divided by 14. So I am getting that marginal value of k as 235. 1 minute. I think it is correct only. Yes, it's correct. 235.099. 1 minute. Let me check the solution here. I have here. I don't have solution here. Leave it. No problem. I don't have solution. Let me proceed. I think it's correct only. Everything is correct. Okay, fine. Marginal value of k, what we found out is 14 point. Okay, this is the row of zeros. Just above the row of zeros, form the auxiliary polynomial using this row. So form auxiliary polynomial using the row, just the above the row of zeros, form auxiliary polynomial. So a of s is the auxiliary polynomial. It is equal to 51.428 s square plus k into s to the power of 0. So s to the power of 0 is 1. I will not write. So equated to 0. Substitute this value of k here. So 51.428 s square plus k is nothing but k marginal value. So we'll substitute here 235.099 equal to 0. So we will calculate what is s square. So s square is equal to minus 235. If it goes minus 235 divided by 51.428, I will do it directly. Minus 235.099 minus, if it goes this side it is minus 235.099 divided by 51.428. So I am getting minus 4.571. Minus 4.571. Okay, fine. So we'll find out the roots. So plus or minus j, root of 4.571. So root of 4.571. So root of 4.2.13 plus 2.137. Okay, these are the intersection points. Intersection points of root locus with imaginary axis. Imaginary. I can cross verify. Let me check here in the diagram. Plus j 2.137. Yes, it is correct. Plus j 2.13 minus, this is minus, they have written wrong. Plus j 2.13 minus, it's correct. Intersection points. Yes. Okay, fine. Then step 7. What is the step 7? Can anyone help me out? What is step 7? Step 7. I don't have one more slide here to accommodate and write here. I need one more slide. Okay, let me show this one only. Okay, no problem. Step 7. Okay, step 6 is, so step 7, no complex conjugate poles are zeros, right? If you observe, no complex poles are there, no zeros, right? So no complex conjugate poles are zeros. Poles are zeros. Since no complex conjugate poles are zeros, you can skip this step. No need to calculate. So angle of departure or angle of arrival. So over. Then step 8, draw the root locus. Okay, I cannot fit within this. Let me go to the next slide. No problem. So I will make use of this slide. Right. So next, previous example continued. Previous example continued. Not this one, right? Previous example continued. Okay. We'll try to draw the root locus. You should be wise enough to take the scale, all those things, right? Sigma j omega. So roots are located at 0, 2, 4, 8. It means minus 2, minus 4, right? 0, 2, 4, 8. 0, 2, 4, 8. So 0, next 2, 4, 6, 8. Let me take it, right? So minus 2, 0, minus 2, minus 4, minus. I have located all the poles. Next, I will locate the breakaway points. Breakaway points are minus 0.785, minus 0.785. 0, 1, minus 0.785 means somewhere it will come here. Minus 0.785. Next, another breakaway point is minus 6.652. 6.652, somewhere it will minus 6.652. This is BAP, breakaway point, and this is also BAP, breakaway point. Okay, the next intersection points we will look at. Plus J 2.13. 1, 2, let me take it here. This is 1, 2, let me take it here, right? Okay, I'll not, okay, plus J 2.137. The next correspondingly I'll take minus J 2.137. Okay, I think this is sufficient. The next we'll look at the centroid and asymptotes. Centroid and asymptotes. What is centroid? Minus 3.5. Asymptotes, when we should know the angle 45 degree, 135, 225, 315. So centroid minus 3.5. Minus 3.5. Let me minus 3.5. So minus 2, minus 3, minus 3.5. Somewhere it will come here. Sigma, right? Sigma equal to minus 3.5. This is centroid. So from this 45 degree. So you have to take this point as center and keep the protractor here and measure 45 degree. So theta 1 equal to 45 degree. And another angle, I think here it is, let me expand 225, I think this one, right? So with the scale, just you can extend it using the scale, no need to measure using protractor. So this is theta 3 equal to 225 degree, I think, right? The next 135 degree, measure it. From here you measure it, it is 135 theta 2. So this is theta 2 and it is 135 degree. Let me check it. 45 over 135 over 2, next 315, expand it, just extend it, 315 degree. So theta 4, sorry, theta 1, theta 2, theta 3, theta 4, right? 315 degree. So I have marked the centroid and asymptotes. Now it is fine. Everything I have taken care. Next, I know that, yes, I will draw the root locus now. Yes, the branch will start here from this 0 and it will come towards this breakaway point. Let me make it thick. And it is coming in this direction. Next, it will depart at plus 90 degree. Okay. Next, another branch will start here and it will come towards this breakaway point. From the branch will start and this is the direction. Then it will depart at minus 90 degree. Then this asymptote is telling this branch to move parallel to me. So initially it will intersect here. So first slowly, just I'll draw, observe here. And it has to move parallel to this asymptote. It is moving parallelly with respect to this asymptote. So this is right and it is moving towards infinity. So it is moving parallel to this asymptote theta 1 equal to 45 degree. It is intersecting the imaginary axis at plus J 2.137. This branch. Another branch starting from minus 2, it will depart at minus 90 degree and there is symmetry here. So whatever it goes here, there is mirror image. So it should intersect at minus, where I have taken this point. I have not taken anywhere. I think let me take it here. Is it fine? Let me take this point here. This is minus 2 point, this one here, minus J 2 point. Okay. So let me make a smooth curve first. It will intersect here at minus j2 point and it will move parallel to this theta 4. It has to move parallel to this theta 4 towards infinity, right? Root locus is over. You can make it thick if you want, right? So you make it thick. I cannot make properly here. You make it thick, right? Okay, two branches. One branch starting from 0, it moves and it intersects imaginary and it is moving towards infinity. Another branch starting from minus 2, it moves, it leaves at minus 90. It intersects here at minus j2 and it moves towards infinity. And another branch will start from minus 4 and it will move towards minus 6.6 with this breakaway point. Yes, another branch will start here from minus 8. It will move towards this breakaway point here. So this branch will live at plus 90. This branch will live at minus 90. Then this asymptote is telling move parallel with me, this theta 2 for this branch. So there should be symmetry, right? So you try to just make a symmetry and try to correlate it and draw it. So this is moving towards infinity, right? Next, this branch starting from minus 8, it will live at minus 90. And this asymptote theta 3 is telling move parallel to me. So it will take a smooth curve. There should be symmetry, right? It is moving towards infinity, right? I hope you got it. 4 branches are there. This is the complete root locus, right? Root locus is over. Root locus sketch, right? Next, comment on stability, right? Stability comments, we will make it. Stability comments. Let me change the ink color. Okay, for k lying between. Right, what is the marginal value of k here? It is 235, 235.099. For k lying between 0 to 235.099 till marginal value of k, system is stable. And second, for k equal to marginal value of k, for k is equal to 235.099, system is marginally stable. Then for k greater than 235, third comment I am writing here. For k lying between means greater than 235.099 but less than infinity. So system is unstable. I hope you got this, right? If any doubts, you can unmute yourself and talk to me so that I can clarify your doubts. Is it fine? Okay. Next, this example I have to take. Next. Okay. Okay, let me change the ink color. This example I'll take up. So I have blank space, I think. Okay, I have very less space, but let me try to adjust within that. So g of s is equal to, let me write it here, k divided by s into s square plus 4s plus 13 s into s square plus 4s plus 13. Sketch the root locus and comment on stability, right? Okay. I hope you understood the previous problems. If any doubts, you can unmute yourself and talk to me so that I can clarify your doubts, right? Or else I'll proceed with this next example. Yes. So we'll draw the root locus for this first. So how many? Step 1. So let me, I don't have space, so let me, or else I'll save and I will come back. Let me see. Okay. How many poles are there? So look at the highest power of s, that s cube, right? So 3 poles are there. So s equal to 0 is 1 pole, and we'll calculate the roots of this equation, s square plus 4s plus 13 using calculator. So go to equation, go to degree is 2 here. So value of a is 1, value of b is 4, value of c is 13. So one of the root I got it as minus 2 plus j something, let me see here, plus 3 plus j3. Next root is minus 2 minus j3, I think, right? Minus j3. So these are the poles. Then zeros, no zeros are there. no zeros. Then p is greater than z, so the number of branches is equal to p, that is equal to 3 branches. And starting point of branches, so they'll start at 0, and another will start at, because pole, right, -2 plus j3, and another branch will start at -2 minus j3, 3 branches over. Then terminating points, so all will move towards infinity because no zeros are available to terminate on them, so all will move towards infinity, right? Next, step 2. Okay, we will draw the pole 0 plot, right? Pole 0 plot. So let me try to accommodate within this whatever I have the space. Okay, let me change the ink color. So at 0, once the pole is located, then -2 is here, -2 plus j3, so it will somewhere it will come here, plus j3, right? Corresponding to it is plus j3, -2 minus j3, somewhere it will come here. We have located the poles, all the poles are located, right? The no zeros. Okay, just we'll see whether the root locus exists in this section or not. Let me take green color. 0 to -2, if I count odd number, yes, odd number of poles, so root locus exists here. Yes, from this branch, so okay, fine, let me not comment anything. Okay, the root locus will start from this branch at 0, right? Okay, fine. Next, from -2 till -infinity, whether root locus, let me consider this point. If I count the number of poles to the right side of it, let me count this complex. You can neglect this, but let me count, no problem. 1 2 3 means odd. From -2 to -infinity also, one minute. Okay, 0 to -2, yes, fine. If I -2 to -infinity till -infinity, okay, what's happening? Okay, let it. So root locus exists here also, right? Is it fine? One of the branch, see here, it will start here and it will move towards infinity, right? From means from 0 to -infinity, this is one branch. Okay, another branch should start from this -2 plus j3. Another branch should start from -2 minus j3. We will find out, right? Okay, are there any complex adjacently placed poles in order to find out minimum breakaway points? Nothing here, right? No minimum breakaway point exists, right? Because there are no two adjacently placed poles or two adjacently placed zeros or 1 0 to the left or nothing, is that all these predictions will fail, right? Okay, step 2 is over. The next step 3. So step 3, I will do it here only because of step 3. So asymptotes. So formula is theta equal to 2q plus 1 into 180 degree divided by p minus z. So q can take value of 0, 1 and so on till p minus z minus 1. So q can take value of, what is p minus z minus 1? So p minus z, 3 minus 0 minus 1 means 2. 0, 1, 2. Because p minus z minus 1, 3 minus 0 minus 1. So 3 minus 1 is 2. So it can take only 3 values. And what is p minus z? Let me write it here only. So p minus 3 minus 0 is 3. Okay. For q equal to 0. So find out theta 1. For q equal to 1, find out theta 2. For q equal to 2, theta 3. If you remember, you can write, or else you calculate. For q equal to 0. So 180 degree divided by 180 divided by p minus z is 3. So it is 60 degree. Next, for this I will be getting 180 degree. You can check it. So 202 plus 1, 3 and 3 will get cancelled. So 180, right? The next q equal to 2. 2 to the 4, 4 plus 1, 5. 5 into 180. So 900 divided by 3. So I'm getting 300 degree. Over. So asymptote is over. Next, centroid. Step 4, centroid. So it is sigma. So formula is sum of real part of poles minus sum of real part of zeros divided by p minus z. So we'll calculate this. Real part of poles. Only real part I have to take. 0 minus 2. I should take only minus 2. Plus j3 I should neglect. So here minus 2 minus j3 I should neglect. So 0 minus 2 minus 2. So 0 plus of minus 2 plus of minus 2. Add all the real part of poles. There are no zeros. Divided by p minus z is 3. So what I will be getting? So write 0 minus 2 minus. It's correct. So minus 2 minus 2 it is minus 4. Minus 4 divided by 3. So I am getting minus 1.33. Okay, let me sketch step 3 and 4, right? So here I'll differentiate. Okay, let me use this part. Okay, step 3 and 4 I'll plot it. You can observe sigma j omega. Okay, let me locate the poles. 0. Okay, poles are not required. Let me look at only centroid. Minus 1.33. So 0 minus 1.33 will come here. Sigma equal to minus 1.33. So let me change the ink color. Okay, from this as centroid, that is minus, measure the angle 60 degree, 180 and 300. 60 degree will come here. So this is theta 1 equal to 60 degree. Next, this is 180 degree. You can write it theta 2 equal to 180 degree. Then theta 3 is 300 degree. Theta 3 is 300 degree. Okay, this sketch shows the sketch of centroid and asymptotes, right? Okay, we'll continue with the further steps. Step 5. Step 5, breakaway points, BAP I'll write. So we know that it is dk by ds equal to 0. Is it fine? So let me get the characteristic equation. 1 plus g of s into h of s equal to 0. So 1 plus, what is g of s into h of s? It is k divided by s into s square plus 4s. K divided by s into s square plus 4s plus s into s square plus 4s plus 13, right? Plus 13 equal to 0. Okay, let me multiply here. S cube plus 4s square plus 13s plus k equal to 0. This is the characteristic equation. So we will take the k, separate k terms one side and s terms one side. K is equal to minus s cube minus 4s square minus 13s. So take the derivative of k with respect to s equal to 0 and equate it to 0. dk by ds minus nx to the power of n minus 1, right? S square minus 4 to the 8 s minus 13. So equate it to 0. So this will be positive 3s square plus 8s plus 13. I can write it, right? So let me find out the roots of this using the calci equation. So degree is 2. Next, value of a is 3, value of b is 8, value of c is 13. So one of the root is s equal to minus 1.33. Imaginary part also I am getting plus j 1.598. 598. Okay, this is one. Another thing I am getting, let me write it here, minus 1.33 and imaginary part is minus j 1.598. So since these are complex valid breakaway points, I cannot tell directly that which is valid. If I want to tell that this is valid means I have to prove the angle condition. You know how to prove the angle condition right now? Prove the angle, just I will write here one sentence here. Prove the angle condition. Prove the angle condition for existence of these points. These points means these 2 points. These 2 points, right? BAPs, breakaway points, BAPs. Prove the angle condition for existence of these points on root locus. So right now I will not prove the angle condition. I will assume that they satisfy or they do not satisfy. Okay, let it be, right? We will not prove the angle condition, right? But if I want to prove that this point minus 1.33 plus j, it lies on root locus means it has to satisfy angle condition. What is that angle condition? We know angle of g of s into h of s is equal to plus or minus odd multiple of 180 degree, right? So if I get odd multiple, so prove the angle condition. I will assume that they'll satisfy. Okay, but if I look at this, I cannot tell minus 1.33 plus j 1.5. You can see here minus 1.33, right? Minus 1.33 will come here plus j 1.8. Somewhere it will come here. I cannot tell whether it is on root locus or not, right? Okay, fine. Okay, let me assume it is there and we'll continue, right? Okay. And I think those are valid breakaway points will not at all come. Let me check it. Next. I have one more slide. Okay, no problem. Next, step 6. Yes, step 6. So it is intersection points. Intersection points of root locus with imaginary axis. We'll see. Already I have the characteristic equation here. S cube plus 4s square plus 13s plus k equal to 0. Is it fine? Okay. So let me form the root array, a root table, a root array. So s cube, s square, s to the power of 1, s to the power of 0. So odd term coefficients 1, 13. 1 and 13. Even term coefficients 4 and k. 4 and k. K is this constant term. Let me mark it, right? K is constant. So let me calculate this element. 13 into 4. Right? 4 into 13. 4 into 13. It is 52. 52 minus 1 into k. K divided by 4. No need to calculate this. This is constant term. It is k. 2 elements, 2 elements, 1 element, 1 element. Next, row of zeros. This will become row of zeros. If I substitute k equal to 52, this will become row of zeros. So marginal value, let me write it here only. K equal to k marginal, and that is equal to how much? 52. So we'll form the auxiliary polynomial from this equation. So we'll form auxiliary polynomial just above the row of zeros. So a of s is equal to 4s square plus k into s power 0 equal to 0. What is this value of k? It is 52. We'll substitute here. 4s square plus 52 equal to 0. So s square is equal to minus 52 by 4. Minus 52, right, divided by 4. So I am getting minus 13. So intersection points are plus or minus j root of 13. So root of 13. So root of 13 is 3.60. 3.60. Is it fine? Okay. So intersection points over. Next, x complex conjugate. Yes, this is a very big problem because step 7 is there here. I cannot skip step 7. So because complex conjugate poles are there, right? Here complex conjugate poles are there. So complex. So first let me take minus 2 plus j3. Minus 2 minus j3, no need to calculate. So we will calculate angle of, because this complex conjugate pole, we will calculate angle of departure phi d. So calculate angle of departure phi d at which point? Minus 2 plus j3. Minus 2 plus j3. We will calculate here. So we know the angle of departure formula. Departure means 180 degree minus phi. Arrival means it will be plus, right? So how to calculate the value of phi? Phi is given by sum of all the angles subtended by poles minus sum of all the angles subtended by zeros. These two, right? Okay, we'll calculate. You look at all the poles and zeros. Yes, at 0 one of the pole is there, right? At 0 minus 2 plus j3, minus 2 is here, plus j3, let me take it here, minus 2 minus j3, this is plus j3 and this is minus j3. Okay, I have located all the poles, 3 poles, right? Then no zeros are there. Then okay, I want to find out point under consideration is minus 2 plus j3. So join from remaining, join the points. So let me, this is the first pole, let me join it, and let this angle subtended, let me call it as angle subtended by first pole p1. Then let me join from the second pole, this is the second pole, this angle subtended, let me call it as 5p2. No need to calculate, it is directly 90 degree, right? So we will calculate 5p1 and 5p2. I don't have zeros here, right? Okay, so this is 0, right? Well, let me calculate 5p1 and 5p2 first. 5p1, so 90 degree plus something, it should lie between 90 to 180, right? That I came to know. So this is how much? 180 degree minus this angle we will do, so that I will get this angle 180 degree. From here to here it is 180 minus subtract this angle, so that I will get 5p1. So 180 degree minus tan inverse of opposite by adjacent. Opposite, this height is how much? 3, right? Right, adjacent is how much? 2, so 3 by 2, opposite by adjacent. Okay, we'll calculate how much I will get. So 180 minus tan inverse of 3 by 2, open bracket, 3 divided by 2. So I am getting angle as 123. It is correct because it should lie between 90 to 180. So I am getting 123. It is correct. 123.69 degree. Next, no need to calculate 5p2. Directly I can write it is, I am measuring angle in anti-clockwise direction. So it is plus 90 degree. Is it fine? Next, what is the summation of 5p? Add those all those angles. Summation of 5p. So add 123, 123.69 plus 90 degree. So 213, 213.69 degree. So 5p, but phi z is 0. That itself, this itself is phi. This is equal to phi, because summation of 5p minus summation of phi z is 0, right? So phi equal to summation of 5p, that is 213. This is phi. So we will calculate the angle of departure. So angle of departure phi d is equal to 180 degree minus phi. Phi is 213, right? So 213.69 degree. So we'll calculate 180 minus 213.69. So I'm getting minus 33. Minus 33.69 degree. So this is the angle of departure phi d, minus 33.69 degree at point, what is that point? Minus 2 plus j3. So angle of departure at another point, minus 2 minus j3, we'll find out. It is exactly opposite, plus 33.69 degree at plus minus 2 plus minus j3, right? We have found out. Next, step 8. Step 8, we'll draw the, sketch the root locus. Sketch root locus. Okay, we'll sketch the root locus. Sigma j omega. If any doubts, please unmute yourself and talk to me so that I can clarify your doubts immediately. I am stressing a lot. At 0, pole is located. Minus 2 plus j3. Minus 2, let me take it here, or let me take it far away. Sorry, this is minus 2. Minus 2 plus j3. It will come here. Okay. This is plus j3. Minus 2 minus j3. Let me take it here. Corresponding point is minus j3 minus 2 plus j, right? Okay, we have located all the poles. Next we will locate all these things, whatever the things are there. Sigma at minus 1.33 minus this is minus 1 minus 1.33 means somewhere it will come here. Sigma equal to minus 1.33 and we'll draw the asymptotes, right? So 60 degree, 180, 300, 60, 180, 300. So 60, 180, 300. Let me change the ink color. 60. So theta 1 equal to 60 degree. Then theta 2 I think 180, right? This is theta 2. That is equal to 180 degree. Then theta 3, symmetry is there. Due to symmetry you can draw it or else you can measure the angle. How much is this? 60, 180, 300. Okay, centroid asymptotes are over. We have drawn. Then root locus from minus, right? This root locus will take. Okay, let me take green color. From 0, this is 0, right? So it will go, one of the branch will go towards infinity, right? Till infinity, right? This is the direction of the branch, one branch. Another branch will start here, but angle of departure is there. Let me draw that angle of departure here, right? So let me take horizontal line for reference so that I can measure, right? Keep your protractor here at this point and measure. What is the angle of departure at minus 2 plus j3? Minus 33. Measure minus 33. From here you measure minus 33. This is minus 33. This angle is minus 33, right? So let me write it, this one. This is minus 33 point, how much? 69. Measure it. Next here plus 33, right? So exactly symmetry is there. So let me mark this angle like this, plus 33.69 degree. So these are the angle of departures from here to here and here to here, right? So next, one of the branch is starting from 0 and it is moving towards infinity. Second branch will start from this minus 2 plus j3. Here minus 2 plus j3 and this is minus 2 minus j3. Okay, initially what it will tell. And let me, I don't know this valid breakaway points are there or not. Let me take minus 1.33 plus j 1.598. 1.5 means somewhere it will come here. So I don't think these are valid or invalid breakaway points because time waste. If I prove this these are valid breakaway points, then I have to consider this, or else I can skip them if they are not valid, right? Okay, let me check it in from this. I have the solution here. Valid breakaway points, break minus as root locus may be symmetrical with real complex breakaway point is not possible. There is no valid breakaway point, so these two are invalid because what is the comment they are telling? As root locus must be symmetrical about real axis, complex breakaway point is not possible. There is no valid breakaway point, so these two are invalid breakaway points. If I prove the angle condition, they will become invalid. So these are both are invalid breakaway points. No need to give importance to them, right? Next, we'll take green color for root locus. Yes, the branch will live here. Intersection points are there. Let me locate intersection points if they are there. Intersection points are plus j 3.6 plus j 3.6. 3 is here, 3.6 will come here somewhere, right? 3.6 plus j 3.6 minus j 3.6 minus j 3.6. Intersection points, right? Yes, it is correct. Okay, it will live here like this from this branch because this is the angle of departure. It should live like this. Let me take green color only. It has to live at minus 33 because this is the angle of departure, and okay, it will live like this, but it has to intersect here. Before intersecting, just see here, you can observe here, it will move and it will take, just like I have to draw it, or else it has to intersect somehow. So let me take till here and let me draw it here and let me make it parallel like this, right? So let me take this, right? and it has to intersect here, and it has to move parallel to this towards infinity. Why I have taken this shape means you can observe here it has to intersect, no, so it slightly it has to leave at the angle of departure is minus 33, so it is moving and slowly it will take a bend or curve. This is rough, you have to draw rough, right? And it has to intersect here. After intersecting, it has to move parallel to this theta 1 equal to 60 degree asymptote. Similarly, there is symmetry here, so you draw the same thing here, draw the same thing here. It is leaving at plus 33, right? It will take a curve or bend and it will intersect at minus, and it will moving parallel towards infinity. I hope you got it, right? So three branches. One branch is starting from 0, it is moving towards infinity. Another branch is starting from this and it is moving towards infinity. Another branch is starting. This is the complete root locus. Next, comment on stability, right? So stability comments we will write. Stability comments. Okay. What is the marginal value of k here? Marginal value of k is 52. So k marginal is 52. K marginal is equal to 52. So first, for k lying between 0 to 52, system is stable. Second case, for k equal to k marginal value, that is 52, system is marginally stable. Then third, for k lying between greater than 52 but less than infinity, system is unstable. Right? Okay, I hope you understood this, right? How to draw the root locus and comment on stability. I hope you understood this. Let me have a cross verification here. This is how you can see here, right? Slightly it is taking and it is intersecting because I have not drawn the graph paper, right? So it almost the shape is same, but I have not drawn it on the graph paper. It is better to draw it on the graph paper and check it. Right? This is how they are getting this, right? And one branch is starting here and it is moving towards infinity, right? So the same comments. Next, this drawing root locus, everything is over. Next topic we will take up. Is it fine? Graphical determination of k for specified damping ratio z. Okay, shall I stop the lecture here because I want to start with a new chapter tomorrow. Okay, still it is there. I can finish it off. Okay, no problem. Another 10 minutes I require. Okay, a graphical determination of k for specified damping ratio of z. Okay, graphical determination of k, we have seen that formula. K is equal to product of phasor lengths of drawn from poles p1, p2, p3 and so on divided by the zeros z1, z2. This we have seen, right? But we are not determining only value of k. It is graphical data for specified damping ratio, means what, for z equal to particular value. If z equal to 0.5, what is the value of k I have to calculate, right? For particular value of z, I have to calculate k. So how to do that, we'll see here. Let me take the complex roots here, right? The dominant roots, what are dominant roots, I'll tell you later on. Okay. Okay, let me make you clear the dominant roots concept. Okay, we have done this example g of s k dude, but here another one more thing I will add to this problem. Determine the value of k for damping ratio of z equal to 0.5. That I will tell you the steps, and before that I will tell you what are dominant roots. Okay, you can observe here there are three branches. Poles are located at 0, -1 and -3. From -3, one branch is moving towards infinity. From 0, it is moving towards infinity in this direction. From -1, this branch is moving towards infinity. Means the poles s equal to 0 and -1, right? They are very much closer to the imaginary axis. So these poles cannot be neglected. These are dominant ones. Dominant roots. Is it fine? Okay, 1 minute. Dominant roots. Fine. These are dominant roots. But observe here, another branch starting from -3, they are moving towards left half of S plane and they are far away from the imaginary axis. So this is not dominant. So I can neglect this. S equal to -3, I can neglect. So actually, if I consider, this is third order system, right? Yes, but s equal to minus 3, I can neglect this. G of s is k divided by s into s plus 1. That's all I will take, because third order system can be converted to second order system, because these dominant roots will decide the stability of the system from 0, right? These roots. But this is anyhow, it is not going to decide the stability of the system. The roots which are closer to the imaginary axis, those roots we call it as dominant roots, and they are going to judge the stability of the system. So s equal to minus 3 can be neglected. If s equal to minus 3 is neglected, we can observe in g of s, if this is neglected, it will be second order, because s plus 3 will vanish because this is neglected. So k divided by s into s plus 1 means s square. Third order system gets converted to second order by using the concept of dominant roots. I hope you got what are dominant roots. Dominant roots are those which are lying very much closer to the imaginary axis, right? From this you can see here dominant root locus. From 0 it starts here, it moves here. This is dominant root locus branch. From minus 1 it starts here, it moves here. This is dominant root locus branch, but this is not dominant root locus branch because it is moving far away from the imaginary axis, right? So s equal to third order system has been converted to second order by using the concept of dominant roots. I hope you have understood what are dominant roots. The dominant roots are those which are lying very much closer to the imaginary axis on the left half of the s plane. Is it fine? Okay. Next. Okay. I was telling about the graphical determination of k for specified damping ratio z, right? Okay, you know this. If there is a complex conjugate pole here, right? We know that for second order system, the roots are minus g omega n plus or minus j omega. These are the complex conjugate roots. So minus g omega n plus j omega n into this, and minus g omega n plus minus this. This will not take. Only this much will take, right? Okay, this from here to here it is j omega n. From here to here it is j omega d, this one, right? J omega d. What is omega d? Omega d is nothing but omega n into under root of 1 minus z square, and this side it is omega n. You can calculate, you will get, because under root of this square plus this square, hypotenuse. If you want to calculate the hypotenuse, under root of this z omega, this square plus this square, I will get omega n only if you calculate those. So they have calculated here and they are getting omega n. Then this angle is theta. From negative real axis we are measuring the angle, right? Okay, this is the complex conjugate root, this point P. From complex conjugate root I will join to the origin and I will measure the angle theta, and that angle cos theta, let me take cos theta, it is adjacent by hypotenuse, right? Adjacent by hypotenuse. So z omega n by omega n is z, so cos theta equal to z I got. So cos theta equal to z, then theta equal to cos inverse of minus z. Okay, I'll tell you the significance, how to find out all these things. Now you just identify cos theta is equal to z and theta is equal to cos inverse of z. Okay, you came to know the formula, right? Cos theta is equal to z. It depends on the damping ratio. If I want theta, theta is equal to cos inverse of z. Damping ratio will be given. This is given for z equal to so particular value, z equal to 0.5 something. We can calculate theta and draw this angle with respect to negative real axis. Don't take positive real axis. With respect to negative real axis, you draw the angle theta in clockwise direction. So, right? So, we'll see the steps how to determine the value of k for particular value of z. So, draw the root locus on the scale of to the scale on the graph paper. Yes, compulsorily if you are doing graphical determination of k, compulsorily you have to go for graph paper, compulsorily, not however we have done, right? On the graph paper, preferably choose the scale, same scale for x and y axis, right? You know how to choose the scale, right? Or else I'll tell you there. Then get the value of theta, calculate the value of theta for given value of z. For example, z equal to 0.5, cos inverse of 0.5, you will get some particular theta. Then draw a line at an angle theta from the origin such that theta is measured from, please keep this in mind, negative real axis in clockwise direction. Observe here, this is negative real axis and it is measured in clockwise direction, right? Theta. Then determine the intersection point of this line with the root locus, that I will tell you, right? Where the, okay, we'll join the line, right, like this after, right? This point will intersect on the root locus. We'll see that. So determine the intersection point of this line with the root locus sketch to the scale. For this point, whatever this point I get, read the corresponding values. That will give me the k, right? For example, minus 3 plus j minus something, you read the complex value, right? So you'll get that for that particular point, apply the magnitude condition to decide the corresponding system gain k. So we will see all these steps, how to do that. for this example. Already we know how to draw the root locus for this example. This we have seen. Directly I will take, right? Sketch the root locus of the system whose open loop transfer function is this. We know how to sketch the root locus and how to comment on stability we know. Next, additional. This I have not told. Now I will be telling this. Determine the value of k for damping ratio equal to 0.5. This one I will take it, right? Okay, all these things I will skip because already we have seen the same numerical in the previous class. Okay, so what is the value of z? It is 0.5. Okay, we have to determine k. Okay, let me, okay, fine. Z is 0.5. So it is asked to find out what is the value of k. Then we know that cos theta equal to z, right? Cos theta equal to z. So what is z? Z it is 0.5. Calculate the value of theta. Theta is equal to cos inverse of 0.5. So we will calculate it. Cos inverse of 0.5. So I am getting 60 degree. Theta is 60 degree. So we will draw from negative real axis 60 degree. So this is the root locus. You know how to draw the root locus. This is the root locus. From this is the negative real axis. This is the negative. From this we measure the angle theta. This angle theta. It is 60 degree, right? Theta equal to 60 degree. From in the clockwise direction, you measure it. This angle is 60 degree, right? Okay. This is dotted line has been drawn here, right? You can observe here, this dotted line at an angle 60 degree from negative real axis. So if you draw this dotted line, it is intersecting at this point P. This root locus, this is the root locus. This line is intersecting the root locus at point P, and I have to read the coordinates because the graph you have to draw compulsorily on the graph and to the scale. Here they have taken 2 units equal to 1 unit for both x-axis and y-axis. What is the meaning of that? I will tell you. See here, 2 units. You can observe here. This is 0 here. This is 0, 2. 2 units is 1 unit, right? So this is 1 unit, right? You can take it. So 2 units is 1 unit. So 0 minus 1 because the 1 unit, 1, 2. These 2 units is nothing but 2 centimeter equal to 1 unit. You have to take in terms of centimeter, right? So these 2 units is 1. So minus 1. Next minus 2. Minus 2 will come here. Next minus 3. Similarly, y-axis scale. You can observe here 1, 2. So this is 1, right? Next this is 2. So plus j 1.73 will come here because this is plus j1. This is plus j2. So between plus j1 plus j2 plus j 1.73 will come, right? So scale should be perfect. X-axis scale and y-axis scale should be same. Okay, draw it and read the corresponding values. Corresponding. What is this value? Read it. So what is this value? Read it. So after reading, I am getting the point P coordinates are coordinates of point P as minus 0.45 plus j 0.7. Observe here. You read it. So here it is minus 0.45. Minus 0.45. If I read corresponding value here, minus j 0.7. Sorry, plus j 0.7. So the coordinates of point P, I got it. So this is the value of S here. It is intersecting here. So for this value of S or at point P, S is what? Corresponding value of S minus 0.45 plus j plus j 0.7. Yes. Okay. We know the magnitude condition. Use the magnitude condition and calculate the value of k for this point of value of s. So we know the magnitude condition. Magnitude of j of s into h of s at point P is equal to 1. This is the magnitude condition. So apply what is j of s into k divided by s into s plus 1 into s plus 3 at s is equal to minus 0.45 plus 0.7 equal to 1. So magnitude of k, magnitude of s, what is s? S is 0.45 plus this one, magnitude of s. S plus 1, this is s plus 1. So take the magnitude. S plus 3, this is s 0.45 plus 3. So you multiply, right? So you multiply this. You take the magnitude under root of 0.45 square into 0.7. So you take this side, So it is 0.83. From this I am getting 0.8321. So here 1 minus 0.45 plus under root of 1 minus 0.45 square. You calculate, you will get this value. From here you will get, multiply all the magnitudes, you will get 1.958 for this value of z. For z equal to 0.5, I am getting the k value as 1.958. So we can go on designing for different values of z. The values of k will be different. I hope you understood this. If any doubts, please talk to me now itself how to calculate this. sketching root locus, commenting on stability. This problem we have done. Additional thing I have added to this question is determine the value of k for this value of z equal to 0.5. How to calculate that I have told you, right? So z equal to 0.5. So we know that cos theta equal to z. So it is 0.5. Calculate theta is 60 degree. So draw a line here like this. So it went, I don't know why it went. So this is 60 degree, right? So it will intersect the root locus at this point. Read the corresponding real value and imaginary value. It is minus 0.45 plus point. Use the magnitude condition. Use the magnitude condition. It went. I don't know what happened. Okay, let it. Use the magnitude condition to find k. Use the magnitude condition. This is done, and we got k equal to 1.95. Okay. I hope. Yes, concept of dominant roots already I have told. Dominant roots are those which are lying very much closer to the imaginary axis. And the concept of dominant roots help us to convert the higher order systems to lower order system. Here I already have told third order system getting converted to second order system because we are neglecting one of the term s plus 3 if you remember, right? Okay, I already told this, and this completes the today's lecture.